The notebook thing? What's that? The homework? Why don't you have it right now?
I got distracted.
Uh-huh. Hurry up.
When can I call for a new dog?
All right. Gabby, go do me a favor. Nicely go into Mr. Calanella's room and get my charger for me. Because now my computer's about to die. All right, quiet please. All right, any questions on the homework before we grade it?
Yeah.
Questions on the homework before we grade it?
Yeah, 26.
26?
Yeah.
All right, let's take a look at number 26. Hush, please. All right, number 26 says the following. It says 560 over 490. 560 over 490. Whose question was this? All right. Tell me what you're thinking when you look at that.
Zeros.
Right. So we're really dividing by 10 here, but if you ever see a fraction that has zeros at the very end on the far right, you can literally, this is a short, you're really dividing by 10, you can get rid of your zeros. I mean, the same number off the top, the same number off the bottom. You can't like just make up zeros. Thank you. But you can absolutely do this. And what you're really doing here is dividing by 10. All right. So now we got 56 over 49. Now the issue is that those are weird numbers. So there's no, other than like the rule of 3 that says add the two numbers, 9 and 4.
What? You just subtract 9 and 4?
9 and 4 is?
5?
What?
9 and 4 is? Hold on.
9 plus
4 and 9.
13.
13. Does 3 go into 13?
No.
All right, so it's not divisible by 3. I do know that 49 is divisible by 7, but maybe it was divisible by 3 as well too. So it's not divisible by 3. Well, 56 is or is not divisible by 7.
It's not.
Hold on.
It might be, but if you subtract it, you get 7 over 49, and then.
Why would you subtract?
Because it's 2. You subtract that.
Why would you subtract?
Because you have improper fraction. When you subtract that.
Why would you subtract?
I know how much you have left.
What does that have to do with reducing a fraction?
It does. So, because I'm saying it's an improper. So if you're going to make it a mixed fraction like I did, you subtract.
But we were making it as a reduced fraction first, and then.
But it makes it easier if you mix.
It doesn't make it easier if you don't reduce the fraction first. For instance, listen please. Listen, if we had left it as 560 over 490, then you have to divide 490 into 560. Clearly goes one time, but you get this big honking number. How about you reduce the fraction first, and then you're dealing with smaller numbers. Now, Jaden, the only reason I'm giving you grief here is because it's not subtraction, it's division. I don't want to say subtraction because the proper term is division. How many times does 49 go into 56? Now, because it's division, we do subtraction. I don't want to say immediately from the start, oh yeah, you subtract. You don't subtract, you divide. Right? Yes, and from that, 56 minus 49 is what?
It's 7 over 49, and then that makes.
Right. Okay, I got that part, but I don't want to say it's subtraction because it's not, it's division. That reduces to, so the question was there any number that goes into 56 and 49? Yes. What? 7. So the point, what I'm saying is, if you can come up with that number from the start, there's less work. 7 goes into 56 how many times? 7 goes into 49 how many times?
7.
Don't you agree that this is a whole lot easier? 7 goes into 8 one time with 1 left over. I would always recommend that you reduce the fraction before you change it into a mixed number. Now, you will absolutely get the right answer if you don't make a mistake, right? But it's much easier to work with smaller numbers than larger numbers. Okay. Anyone else? Here we go. Number 2 is 15. Now, remember, they're only giving you the answer for the question mark. You know, if you have circled 15 over 21, well, then you're right, but 15 was where the question mark was. Number 4 is 8. Have I lost anybody? Number 6 is 7. Number 8 is 21. Number 10 is 12. Number 12 is 3/5. Number 14 is 3 4/7. Number 16 is 2/3. Number 18 is -7/9. Number 20 is -5 4/5. Number 22 is 7/9. Number 24 is 3 1/5. Number 26 is 1 1/7. Number 28 is -7/12. Number 30 is -38 1/2. That's an ugly one. Number 32 is 17 over 8. Number 34 is 99 over 16. Number 36 is -35 over 8. Number 38 is -49 over 3. And 40 is -83 over 10. Questions? All right, make sure your names are on those. All right, moving on.
Gotta get belt, cause I have my shirt tucked in. Yeah, fuck your shirt. I can't. We'll go get Ooflay. That is my belt.
Landon has already talked to me.
Can I call? Because I can't play basketball with like glue.
We're gonna handle this at the end of class, not the start.
You don't even play basketball.
Oh yeah.
All right, to everybody else, while all that's going on, you guys need to look at the calendar. We have a quiz on Wednesday. That is in 2 days. Tomorrow, we will talk about what's on the quiz. However, today, this is your, where's the homework? There it is. There's your homework. Please copy it down. Genevieve.
No, you better.
Is it 2 weeks? I believe 2 weeks. Just so that you know that the quarter for math just ends. It's not that we have any big test at the end of the quarter or anything like that. It just ends. So we continue on the pace. Like if we're not done with chapter 4, we're still going to continue on. That means potentially, you know, the first day of the quarter could be a test. So the only time that we have a definitive end, like I'm going to end somewhere specifically, is semester. So the semester is the semester will be unlike last year, which was, because we started late, was the first or second week of January. We had semester finals. This year, we will have semester finals right before Christmas break. So it'll be your standard. We'll do 3 days. You're in upper school now. Well, you were last year as well, too. 3 days of semester finals, meaning you're going to show up to school. You're going to take 2 or 3 finals and you're going home. Right? And that's all you will do. Right? For 3 days. And they will all be half days. So the only thing you're going to do is you're going to show up, take a test, go home. And it'll all be half days. And that's the end. Yes?
How's that gonna work?
I don't know. Good one. We'll figure that one out. You got younger brothers and sisters?
No. An older brother.
Oh, then they'll be fine then. I just literally realized you're McKinley's brother. I did not even put that together. Cool. McKinley is unique. I'm being recorded here, so I gotta be nice. No, I like McKinley. But he is definitely his own person. He sails a different route than many people. Do you ever get on the ground and act like you're a spider?
No,
Okay.
David, don't act like a monkey today.
Right. Okay, there are only a few things in, listen please. There's only a few things that kids get to 8th grade and they still struggle at. Okay, let's see, decimal division, decimal multiplication, and adding and subtracting fractions. That's what we're working up to. Now, I will not teach you anything new, right? At least for dealing with decimals and fractions, right? You already know how to do this stuff. So this is all just a quick reminder. To go on to Algebra 1, I mean, like, you will never, ever again have a class on how do you add fractions. It's just like, add these two fractions, right? This is your last chance to get this right. Like I said, I don't necessarily spend a lot of time teaching you adding, subtracting fractions. What we spend time on is the fact that we're going to be dealing with positive and negative fractions, okay? We're working our way up to next class, how to add, subtract fractions. All right, in order to do that, as you know already, in order to add or subtract fractions, not multiply or divide, but to add or subtract, you have to have what's called common denominators. This is a different method of getting to that. Instead of talking about denominators, as all classes do, you get this class on something called least common denominator, right? The least common denominator, right? You can have common denominators of any common multiple. But in order to make the math easiest, we would like to choose the smallest number. Sure, 1/2 plus 1/3, right? 600 million is a common denominator. You do not want to choose a very, very, very large common denominator. It requires a whole lot more work. So we would prefer to choose the least common denominator. In 4th and 5th grade, you start learning about these things called factor trees and a method of creating these things. By the time you get to 8th grade, right, we basically say, good luck, make a common denominator. We don't spend much time. And it's not because those methods don't work. It's because most students really kind of realize pretty quickly on that there's the tried and true method of guess and check, or I just go through the possibilities. And that's kind of where we settle on higher than 8th grade is, hey, make a common denominator, right? Although today I will show you least common denominator. We generally say, hey, just get a common denominator. So where are we going with this is, next class tomorrow, we got to add, subtract positive and negative fractions. Okay? So today's class is just on making a common denominator. So for instance, if I ask you to add 2/5 and 3/7, we got to come up with a common denominator. All right, write this down, please. Box 1. Least common multiple. It doesn't say least common denominator. It says least common multiple. This is the smallest multiple shared by a given set of numbers. It's abbreviated LCM. When you find a common denominator, what you're technically doing is finding the least common multiple. Jaden, you can't have a question right now. Write this down. You can't have a question right now. Just write the definition down on the piece of paper I gave you, unless you didn't get a piece of paper. Is that your question? Okay. We'll get to your question, just not right now. Now, you guys have been taught this before. In fact, they spend a lot of time on this. They have you make a factor tree. They give you some rules. You spend like half a chapter doing this, and then whoosh, I'm doing the flushing symbol. You flush it from your brain, and you don't remember it. Yet somehow you guys know how to add fractions together. Somehow in your mind, you've kind of taken what you've been told you're supposed to do, and you've changed it into, well, that's great. Now let me do it the way that I think is easiest. So I don't fight that battle anymore in 8th grade. I just basically say, okay, well, then let's go with what your thought process is. I have taught the method of the factor tree and whatnot. I just tend to find too many kids forget the rules, and it's also a lengthy process, right? To find the least common multiple, this is what most people do. They do not do you guys remember doing factor trees?
Yeah.
Right? Do you remember the rule for finding the least common multiple using factor trees? What?
The ending has to be prime number.
No, that's part of the factor tree portion. But how do you find, once you make your factor tree, the least common multiple? That's the part that everyone forgets. So I don't teach that. Here's what I teach is what I would argue, what most people do. Can you guys count by 15s?
Yeah.
Count by 15s.
15, 30, 45, 60, 75,
Can you
90,
count by 20s?
20, 40, 60, 80, 100.
So what I'm going to argue what most people do is that's the process. They just do that in their head. So the question is, should you count by 15s or should you count by 20s? Okay, yes.
No, but I think we should do always the lowest one because then it could
Occasionally, the lowest one goes into the largest one. So I would recommend the same thing. If there's a alternate, please be careful, right? If there's an alternate, please. If there's an alternate to this, right, that is write down just a few multiples of 20. So we do know that the common multiple here, or the least common multiple, is 60. The question is, right, how did you do that? And I'm going to go with what she said as well, too. I'm going to count by my smallest one until I get to a multiple of the largest one. Genevieve, you want to say something? Okay. Please stop. Write this down, please. There's no tape over there. You're not stapling this. Okay. Write this down, please, also in box 1, the least common denominator. Notice this says LCD. This says LCM. They're really close together, right? You will be finding least common denominators. That's just a fancy word for finding the least common multiple. Some books will call it the lowest common multiple, or the smallest common multiple. Please stop. Let's get serious here. Right. Box 1. All right, so least common multiple, least common denominator. Well, one we're talking about denominator, one we're just talking about multiples of couple numbers. The concept, though, is the same. To find the least common multiple, you are finding, the least common denominator, you're finding the least common multiple. Now, I understand it's confusing. And most of you could already find it without me telling you the names of what you're doing. Box 1, write down both definitions. All right, so we got the Callie method, and we'll call it the Mr. C's method. Callie method is she's just going to count by the smallest one, but she's going to think about the largest one. Mr. C's method is we look at the largest one and we write maybe a couple of the multiples down, like we physically write 20, 40, 60, right? And then we count by the smallest one. On an easy one like this, maybe you don't do any of that, and you just immediately know the answer is 60, and that's because of your basic math facts, like you're familiar with 15 multiples and the 20 multiples, okay? But when you're not, if it's 17 and 31 are the two numbers, you know, you're going to have to write down multiples. You might actually do scratch work on this. When they're really weird, like 1731, I might argue that the factor tree method will give you a quicker answer, and it will be true. The issue is, though, you're going to have to remember that. No one forgets, just count. Just give me the multiples. So I choose not to even go back to the factor tree method. All right, we good? All right. So, for instance, if you're adding 7 over 15 and 11 over 20, we know that the least common denominator is something over 60, something over 60. Okay, this is what we'll be doing tomorrow when we add or subtract. And by the way, our fractions will be both positive and negative for tomorrow. So finding the least common multiple, right? The two techniques are called the brute force method. This is the Mr. C or Callie method. Right? You literally just count multiples. And the other method is called prime factorization. What Jaden was saying, hey, he remembered it had something to do with prime numbers. Most people completely forget how to do the prime factorization model. No one forgets the brute force method, so I'm only going to show you the brute force method. Yeah.
Wait, are we
No, you don't.
Are we doing negatives today?
No.
There's some of those on the
Well, we're not going to be adding, subtracting them.
Yeah, I know, but
So we'll be making the least common multiple or least common denominator of positive number. That's fine. Okay, so I'm going to show you brute force. The brute force method is this. Okay, I'm going to give you two numbers, and we're going to say, well, what's the least common multiple of these two numbers?
28.
So Callie said to just count by fours, right, until you get to a multiple of 7. Now, if you're aware of the multiples of 7, that method works. But sometimes you won't be aware of the multiples of the larger number. Okay? So in that case, I would recommend don't do too many of them. 3 to 5 multiples, 7, 14, 21, 28, 35. If you have basic, I don't know, math sense of the numbers, even doing that process, you might be aware of when you get to a multiple of 4. Well, let's just say you don't. So my recommendation is, and it's a recommendation, is to you write 3 to 5 of these down. Then start counting by fours until you get to a number on the list. So 4, 8, 12, 16, 20, 24, 28. Okay? You'll stop when you get to a number on this list, or you get to a number bigger than 35. If I count by fours and I don't find any matching number and I get to a number bigger than 35, then I got to increase these numbers. Genevieve?
What if we just did stuff times 4?
Are you guaranteed to find the least common multiple? She said, can't we just multiply 7 times 4? We get 28. Are you guaranteed to have the least common multiple?
no.
And the answer to that is no. So for instance, if the two numbers are 28 and 22, you want to multiply those two numbers together? So you're not guaranteed that it will be the least common multiple. However, we'll call this the third technique, the Genevieve technique, right? You are guaranteed that the two numbers multiplied together is a common multiple. You're just not guaranteed that it's the least common multiple. That third technique right there, it doesn't really have a name. I call it the Genevieve technique, is absolutely 100% used. But when it's not the least common multiple, you just gave yourself extra work. Okay? In this case, it just coincidence turns out that it is the least common multiple. So when you find something matching on the list, you're done. Put LCM equals 28, you're done. All right, one more time, 8 and 12. Now, granted, you guys have number sense. I'm just showing you nice friendly numbers to start this. So I write a couple multiples of the largest number, 12, 24, 36, 48, right? 60, right? And then I write multiples of 8. When I get to a matching number, 8, 16, 20, oh, I can stop. So using the Genevieve technique, she would have gotten what? She would have gotten what?
A big number.
96, right? So her multiple is 96, our multiple is 24. It's not that hers is wrong. It's not that she can't use that. It's just that the math is a little bit easy with the least common multiple. When I look at them and I go off, I mean, I'm not going to do this. Like, for instance, when they're really weird, 17 and 11. Okay, 17 and 11. That's going to take some work. I can count by 11s. I can't count by 17 past 34, and then I got to think. So when I get some really weird ones, occasionally I'll just go ahead and use the Genevieve technique. 11 times 17, I'll just deal with the ugly math. But when they're easier numbers, like 8 and, I don't know, 18, I'm probably going to write multiples. Okay. Who's lost on that, or you've never done this before? Right? All right, lost or just never done it before? Okay. So how do you, when you were asked to add fractions, what did you do? So you did the factor tree method. Do you remember the rules? Thank you for admitting that. No one remembers it. People remember how to do the factor tree. Factor tree, Jaden, give it to me.
That would be 2 and 10, 2 and 5.
And you're done.
No, there's
2 times 2 times 5. You're
It's
done.
also 3.
What?
What? You're
Okay,
crazy, bro.
That's it. Give me the factor. Go.
2, 8.
8,
Keep going.
2 and 4, 2 and 2. 2 to the
2 times 2 times 2 times 2, right? All right, now what do you do with those two things? See what I mean? Nobody remembers. No. I'm just saying, whenever the lower school teachers come and ask me for advice, it's always about this. Hey, how do you teach this? I'm like, I don't teach it. I think it's a waste of time because no one remembers it. You know, I have plenty of people that remember how to add fractions and they do it correctly. So this is a cool, nice trick, and mathematically is sound. Mathematically will get you the right answer. It's called the factor tree method. Prime factorization is really called. Just that no one remembers the next step. All right, and so I'm not even going to talk about it. So for us, we're going to use the Cali method or brute force method, which is just, hey, give me the multiples of 20. 20, 40, 60, 80, 100. Oh, you could probably stop. Wait, I can't count by 16s. So this one, that's why it's called brute force. We got to, you know, actually go through the calculations. All right, so 20, 40, 60, 80. Let's count by 16. 16.
32, 48.
We can get to about 48, and then we kind of slow down. So let's see. 48 and 10 is, 48 and 10 is,
58.
plus another 6 is, okay, we're not there. 64 and 10 is, plus 6 is, oh, we're done. Okay, so not too much brute force. Okay, but I'm just saying I don't have the math facts of 16 memorized. Okay, yet this method didn't take too long. This is 100% scratch paper work. Like I don't really want to see this work right here next to where you're adding, subtracting fractions. It takes up too much space. I want to see least common multiple is 80. Once again, if Genevieve were doing this, she's multiplying 16 times 20. That's a pretty big number. Her method will work. Now we got to deal with really, really large denominator. Because remember, where are we going with this, right? We're going to be adding fractions tomorrow. Okay, 22 and 88, seemingly small numbers. What's the answer? How do you know? How do you know that one of the numbers in between isn't the answer? Do you know?
No.
We don't until we actually brute force this sucker. So let's see, the largest number is 22, 22, 44, 66. I mean, I know right now that 88 is a factor. I got to convince myself that 44 and 66 aren't. Well, I know because I've got my 8s memorized. I'll buy that argument. By the way, this is probably all the work you need to do, right? Because you can count by 8s. You know that 66 isn't the right number. 44 isn't the right number. You can stop right here. I don't actually have to write 8, 16, 24, blah, 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 right? I don't need to write that. As soon as you go through this list, you could have stopped right there. And that's because we know our 8s. But if this was, I don't know, if this was a 12, right? Well, then I got to do some work. Have I lost anybody? Is this what you guys do when you add fractions? Is this the method you do? Do you use Genevieve's technique?
No.
What do you do?
Well, hey, just give me a number. Like,
Okay,
give me a
what's 113 plus 115?
number.
What do you do?
Example. Well, yeah, I do that.
Okay, that's my
I
argument.
don't write it down.
I know. Well, this one you probably do because you can't count by 13s or 15s that easily. Okay? My argument for this method is this is what everyone does. Everyone's taught the prime factorization, and then somewhere along the line, like, yeah, that's great. I'm not going to do that anymore. I'm going to use my own method. Everybody comes up with this method. So why don't we just teach this method? By the way, the book does prime factorization. Okay? All right. Got it? All right. So can you find the least common multiple of the given numbers? Right. So all we're going to do is extend this idea to fractions and making an equivalent fraction. Tonight for homework, they're going to ask you what are the two equivalent. They're not going to ask you to add them or subtract them. They're just going to ask you to make the equivalent fractions. So here are two nice, easy, friendly ones: 3/4 and 1/3. Now some of you could do this in your head, right? But we're going to We're going to do this. Jenna, yep, on board? Can you count by 3 and 4? Hey, count by 3s for me. Or count by 4, it's the biggest number. Count by 4s. For those of you that are, that I say have a multiplication table, guess what you're doing? You're just reading off the 4 row. 4, 8, 12, 16. If you have a multiplication table, and since I allow that on quizzes and tests, right? Well, then you got all the answers there right in front of your face. Who's got a multiplication table right now? Pull it out. Right? In other words, if I look at the multiplication table, I'm just looking at 4 and 3. And I'm looking at those rows until I find a matching number. It's really easy to do with a multiplication table. I'm not saying everybody get a multiplication table, okay? But I'm saying for those of you that do, it's pretty simple. So I got a small number, I got a big number. I count by the big number first, 4, 8, 12. I'm going to stop at about 4 or 5 of these. 4, 8, 12, 16, 20. Then I count by 3s until I get to a matching number. 3, 6, 9, oh wait, 12's match. Okay, you just found the least common denominator. The least common denominator is 12. You're like, isn't that literally what we just did? Yeah. Least common multiple, least common denominator. It's the same concept. Okay. Where we're going with this is we're going to take this sucker. The last thing we do today is we're going to make 2 equivalent fractions where the denominator is 12. Yeah.
Wait, wouldn't that be 16?
Say what? Oh, we'll get there in a second. We're not there yet. We got to find the common denominator first. And we want the lowest common denominator. Okay. Oh, by the way, Genevieve, 4 times 3, here's an example where they literally are the same. All right, let's try one. Box 4. Using her method, 7 times 6 is 42. Maybe the answer is 42. Maybe. Guaranteed it is a common denominator. It just might not be the smallest. So we take the largest number, 7, and we count by 7s. 7, 14, 21, 28, 35, 42. Yeah, it's going to be 42, isn't it? Right? We count by 6s, 6, 12, 18, 24, 30, 36. As soon as I get to a number that's bigger, I gotta give myself some more numbers over here. All right? Everybody see what I'm saying?
Yeah.
All right, so I gotta go to another one, 42. Oh, that's the same number. So here's another one where literally multiplying. Just remember, it's not guaranteed to always be the smallest. Yes?
Yeah.
Okay. Box 5. Is this a silly one or a reasonable one?
A reasonable one.
No, this is a silly one. Look at the 2 numbers.
Oh, shoot.
Look at the 2. It's not 10. 10 is incorrect. We got to count by the largest number, but wait a minute. The smallest number goes into the largest number, so there's no work.
So it.
The answer is always the largest number if the smallest number goes into it. Yes.
So, won't that be 27?
We'll get there. We'll get there. We'll get there. All right. So I'm not even doing any work here. I already got to an answer. Now, granted, I am technically doing a little bit of work. 90 is also an answer, just not the least common denominator. All right. So yes, finally for Genevieve and others, we will get to what's this all about. What this is all about, in order to add fractions, you have to have common denominators. Hey, remember the old pictures of pizza? And I said, you know, the crummy pizzas are where, you know, there's a big slice and a little slice, and your sister grabs the big slice and you're left with a little slice. We want our pizzas to be cut with equal slices. That means all the slices are the same size. That way, if I have multiple slices, I can count them. If I've got a big one and a small one, well, they're not the same size. I can't say 1 slice, 2 slice. They're different sizes. So in order to add, that would be counting, grouping. In order to subtract, taking away, we need to make sure all the slices are the same. That's why we make common denominators. Grayson? Hurry up. What?
Wait, but square pizza is almost always
Say again?
Square pizza is almost.
So maybe our pizza should be cut in squares. Problem is the end of the crust, somebody gets wound up with a little tiny one and a big one if you cut it up in those squares. All right, so what is that next class we will add and subtract, I know I've said this before, we will add and subtract the fractions, but in order to do that, we have to have our slices, the pieces of the fraction, all be the same size. That's what a common denominator is, okay? So to add these two together, we got to make sure that all the slices, because right now, this slice is really big, this slice is really small. We need our slices to be the same size. In order to do that, we're going to make common denominators. So we look at the largest one, it's 10. We count by tens until I get to a multiple of 4. You should be able to do that one in your head. This is an easy one. But if you can't, then we count by tens. 10, 20, 30, 40. Right? Most of you should have stopped at 20 when you realized that, wait a minute, 4 goes into 20. If you can't, then scratch work off to the side. You need to write your multiples of 10 and then your multiples of 4 until you find a matching number. If I'm losing anyone. Is this brand new for anyone? Jackson, put your hand down. All right. So let me just go through one example first, and then I'll entertain your question. Okay. So we just found out that the lowest common denominator, least common denominator is 20. Great. So what? We now combine this class with the last class, making equivalent fractions. Jaden, turn around. Okay. We now combine this class, finding a common denominator, with the equivalent fraction class. I need to make 2 equivalent fractions where the denominator is 20. Scratch work, off to the side. My first fraction is 3 over 4. That's going to look exactly like your homework over the weekend. My next fraction will have, this looks familiar, question mark 20. Hey, this is what you did last or over the weekend, homework. Okay, how do you go from a 4 to a 20? Multiply by 5. So we're going to multiply top and bottom by 5. Therefore, the question mark is actually, so the final answer for 3/4 is 15 over 20. Oh, but we're not done because there were 2 fractions. Jenna, stay with me. 2 fractions. Second fraction, we still also need to make it a common denominator of 20. Scratch work, off to the side. I got to turn 1 over 10 to something over 20. How do you turn a 10 into a 20? Times it by 2. Therefore, the question mark is equal to 2 over 20. There's my 2 fractions in yellow. Tomorrow we'll add or subtract or something with them. But today, you're just making the 2 equivalent fractions for the 2 original fractions that do not have common denominators. 4 and 10, not the same. But look, we wind up with 2 fractions that have the same. Now I can tell how many slices we have. Oh, by the way, how many slices do we have? How many slices do we have? I'm kind of jumping to tomorrow's class.
Wait, are we adding?
Well, if this was pizza, we'd have 17 slices, right? The whole pizza has 20 slices, but we have 17. Now that's the, I will talk about tomorrow. All right. Now, they are going to, because you're in pre-algebra, combine positive and negative fractions. The process doesn't change. Just one answer is negative, one answer is positive. All right. We got 9 and 6, 9 and 6. Okay, first step. Hannah, can you do the common denominator in your head there? Can you look at those 2 numbers and just tell me the common denominator? Is it 18, class?
No.
Yeah.
Yes.
Okay, I'm just going to say this again. You guys have made it to 8th grade. Somewhere along the line, you've wrapped your head around this concept. I showed you a technique. I saw Hannah. She looked immediately to the skies, and her eyes went left, right, left, right, left, right. She said, is it 18? There's something going on in the brain. Hopefully, it's kind of the process I just showed you. Right? Was that kind of what you do? You're like counting by 9s or 6s, or you're counting by both?
I kind of like
Yeah. That's the way I do it as well too, but that's only if this number right here is a number I can count by. I mean, if this number was 26, right, then counting by nines isn't going to help me. So you might have to, on a separate sheet of paper, do some scratch work for your multiples. She's right, though. It is absolutely 100% 18. Just remember, Genevieve said we could always multiply 9 times 6, 54. 54 is a common denominator. It's just not the smallest one. And the smallest one will require the least amount of multiplication. All right, so I need to take each fraction, 2 over 9 to negative 1/6, one at a time. Scratch work, right? And we got to turn it into something over 18. What are we multiplying by? What are we multiplying by? Stay with me, class. 2's. Is it a coincidence that the top is 2?
Maybe.
Yes. We're not multiplying by 2 because the top number is 2, the numerator. We're multiplying by 2 because that's what times 9 is 18. Don't assume that because I'm multiplying by 2, it's because the numerator was 2. 2 times 2 is 4, so I get 4/18. You got to stop me if you're not with me. Second fraction, negative 1/6. Negative 1/6. It's the same process, just ignore the negative for a second. We got to turn it into something over 18. It's still going to be negative, right? What times 6 is 18?
3.
So we multiply 3, this time 3 times 1, we get negative 3 over 18. Do not forget, for this process, if we start with a negative fraction, we end with a negative fraction. I didn't say what happens when we add or subtract them. That could be anything. But if you're given a negative fraction to start with, your equivalent fraction will also be negative. If you're given a positive fraction to start with, your answer will be positive. Does that make sense? Okay. Occasionally what happens is, guess what? Kid will do the work, and then all of a sudden, guess what happens?
They fail. Do bad on the class.
Somehow the negative fraction turns into a positive fraction. This is called literally dropping the negative. They start with a negative fraction, and for some reason, because they do scratch work, it turns positive. You start with a negative fraction for this process, right? You end with a negative fraction. The answer could be positive or negative once we add or subtract. But if you start with a negative fraction to make an equivalent fraction, it's negative. Start with a positive, it's positive. Let's do one together. Here we go. All right. 9 and 12. Is that one you can do in your head, or you need to write it down?
In my head.
All right. Well, what's the answer then, head people?
12.
36. Okay. Agreed? 36?
Yeah.
9 times 12 is not 36. It's a big number. 108. Okay. We can use 36. So the least common denominator is 36. I take each fraction one at a time. One at a time. There better be the right answer here, or you're doing more homework.
No,
All right.
I never agreed.
Even then,
I don't even think I got
All right.
it. Whatever.
So here we go. You're wrong.
Yes.
All right. Extra homework for you.
Here
we go. 36. We take the first one. 4 over 9. We need to turn into something over 36. What are we multiplying by? Well, I should change these numbers. It's a coincidence that we're multiplying by 4. Okay. Stop. It's a coincidence that we're multiplying by 4. It's not because the numerator is 4. It's a bad math teacher example right here. Okay. 4 times 4 is 16, so we get 16 over 36. That's the part where you got right, Landon. The part where you got wrong was the second one. Literally, I just said, guess what your mistake will probably be?
The second
Guess dropping a negative.
one.
All right.
Are you joking?
So we start with negative 5/12. We need to turn into something over 36. What times 12 is 36? 3 times 5 is, you don't get 15 over
Negative
36.
15.
You get negative 15 over 36. There's your mistake. Okay. And that one mistake, and we haven't even done the adding or subtracting yet, what we'll do tomorrow. You make that silly mistake right there, it throws everything off. All right. Box 7, let's see. 7 and 5, who's got it? Common denominator.
27.
What do you got, David? 35. So here's one where it is literally the two denominators multiplied together. So we got 35. We take our first fraction. Right? And we set it up. You don't even have remotely the right answer here. You're gonna get special homework.
No.
right. The rule in class is you certainly can work ahead, but only if you're doing it correctly. Right? All right. What times 7 is 35? 5. So 5 times 2 is 10. We get 10/35. Second fraction is 2 over 5. We need to turn this something over 35. What times 5 is 35?
7.
So we get 14/35. There are the two answers that should be on your paper. Lanny, you don't have either one of those. All right. We good?
Yeah.
All right.
No.
What if instead of 2, you clearly have the wrong answer. What if instead of 2 we had 3 of these? What would we do? What do you think, Callie? Do the same process, except we got to do it for 3 numbers. Landon, stop. Both of you. You stop and you stop. Okay. Landon, what's the common denominator? Oh, this one requires some thought.
Think.
This one requires some thought.
Wait, no, stop, bro.
Hey,
So-
stop.
60.
Okay. Our guess is 60. Let's confirm.
Yes, it's a confirm.
What's the biggest number here?
5.
Let's count by 5s. 5, 10, 15, 20, 25, 30. I'm going to stop at 30. You count by 4s, right? Is any number on that list, I counted by 5s at the 30 on that list?
Yes.
Okay, 20. Does 3 go into 20?
No.
Didn't work. We got to continue. We stopped at 30. All right, 35, 40, 45, 50, 55, 60. Any number on that list?
Yeah, 60.
Well, 40 is, right? Does 3 go into 40? What's the next number on that list? 60. Does 3 go into 60?
Yes.
Yeah.
All right. Now, this one is also one of those ones where if you multiply all 3 numbers together, you do in fact get to 60. Don't convince yourself that 60 is the least common denominator simply because that's what the 3 multiplied together are. There might be one in between, but you're not going to know that unless you think about the 3 numbers. Questions on 3? All right. Last game is this. They're going to give you 2 fractions, and they're going to ask you which one is bigger or which one is smaller. In other words, they want you to use greater than or less than or an equal symbol. The issue is this. They're trying to trick you. They're going to give you 2 numbers that are really close together. In order to do this properly, don't rely on your instincts. Rely on math facts. In other words, make common denominators make equivalent fractions. So 5 and 4, what's the common denominator?
20.
20. So I'm going to take the first fraction, right? What times 5 is 20?
4.
So what's the fraction now?
8 over 20.
Wrong.
4 over.
Wrong.
8 negative.
Say it.
8 negative 20.
Say it correctly.
8 over 20 negative.
Wrong.
Negative 8 over 20.
Thank you.
Just said that.
He was trying, but it was hard to get out. He said 8 negative over 20. I'm not sure what that even means. All right. Second fraction, negative 1/4. What times 4 is 20?
5.
So what's the fraction?
Negative 5 over 20.
Now you have the 2 fractions. Notice I'm putting them next to each other so that I can compare them. Now be careful. Which one's bigger, left one or the right one?
Left.
You are so wrong. It is sad, Landon.
Right.
Oh, yeah. I forgot.
Remember, when you deal with negatives, and that's a common mistake. He won't be the only one that makes that mistake. When you deal with negatives, as the number increases, what happens to the overall value? It decreases, right? Negative 8 is smaller than negative 5. So the larger one was the one to the right, negative 5/20. Notice, if you had looked at these 2 fractions and you had used your, I don't know, instincts, you might want to say that 2 is bigger than 1, so therefore that's the bigger one, but it turns out that negative 1/4 is actually bigger. Okay? You got to be careful. Yeah, got to be careful. All right, let's do one more. Box 8. Box 8.
Oh,
Notice when the numbers are really far away from each other, it's harder to do instinctively.
right.
All right, what's common denominator?
16.
6, 0. So one at a time. Oh, we're out of time. All right. Questions on anything we did?
No,
For those of you who did, here's the other answer.
we'll get
Landon,
A.
seriously, I need you to be a bit more serious in class. Yeah. All right, e-learners, if you have any questions. Yeah. No, we're done with it. E-learners, if you have any questions, ask me a question. If not, I will see you guys tomorrow.